What is a derivative? To answer that, we need to go all the way back to grade 9. In grade 9, we learned this thing called the slope of a line, and it measured the steepness of that line. It was also called the rate of change of y with respect to x, because you're literally going y2 minus y1 divided by x2 minus x1. So it's change in y divided by change in x. So a key takeaway here is that the slope of a line measures the steepness of that line. Now, let's take that blue line that we had before, and let's draw a red curve through those 2 points, okay? So now, we call this blue line a secant line because it joins 2 points on the red curve together. Let's also rewrite the second coordinate, right? So we have x2, y2, but I can write x2 as x1 plus h, where h is the separation between x1 and x2. Let me pose this question. Highlighted in green, it says, what happens when h becomes really, really small? Meaning, what happens when the separation between the 2 points becomes very, very tiny? The 2 points actually become 1 point, and a secant line becomes something called a tangent line. So the tangent line is a line that you draw through that 1 point. In this case, it was x1, y1, but I just called it xy in this case. I call the slope of a tangent the derivative. Going back to the slope, if the slope measures the steepness of a line, the rate of change of y to x, the derivative measures the steepness to the original red curve at any given point, xy. All of this is exactly why, when you first learned the derivative function, you learned this thing called first principles, which is essentially taking a secant slope and forcing h to be really small. And then in the end, you get this thing called the derivative function, or the tangent slope function. This will tell you the steepness of the original curve, f of x, the red curve in our previous example. It'll tell you the steepness at each and every point, no matter what x you plug in. Let's take a specific example. In this case, let's take the red curve to be f of x equals x squared. That is a parabola, and that is precisely why I've drawn a parabola down here. You are exposed to calculus, you learn the first principles, and you find the derivative function for this parabola. What do you end up getting in the end? You end up getting that f prime of x equals 2x. But what does this mean? This means if I were to draw any sort of tangent line on this curve, I would get the slope of that line. For example, suppose I draw the tangent line at x equals 2. When I do that, and I plug in x equals 2 into this derivative function, then I will get this value of 4. That means that the slope of this line right here at x equals 2 is 4. The steepness of the original curve, y equals x squared, at x equals 2 is 4. Let's look at an even simpler example, f of x equals 3x. When you draw f of x equals 3x, you get this thing called a line, a straight line. That straight line has the exact same steepness, right? No matter what x value you look at, it has the exact same slope of a tangent. This is why when you find the derivative of f of x equals 3x using the first principles, you will get a constant, number 3 in this case, because the steepness is constant. It's the exact same steepness throughout. Here is a summary of all of the points that we discussed in this video. If you guys really enjoyed this content, it would really help us out a lot if you supported us in any way, liking, subscribing, or commenting on this video. Thank you so much, and we'll see you in the next one.